Hey guys, I'm going to go through this Module 6 review. I'm going to try to go through it quickly because there's 24 problems, I believe, or 23. And I know that this could be lengthy and boring. So I'm hoping that you understand at this point, and just a brief review will be enough. So I'm going to start with the 5, and I always do one number to the left and one number to the right of 5. We know that we want a closed circle because we are including that point, and we are looking for all the values that are greater than that, so we point to the right. So there is the solution graphed. Here it says graph the solution of x is less than -2. Again, I'm going to go -3, -2, -1. Open circle because we're not including, and we're looking for all the values less than -2, so we point to the left. Now we need to write an inequality representing this. So here's 0, this is 1, 2, 3. So we're looking for all of the values of x that are less than 3. All the values of x, pointing down this way, that are less than, not equal to, because it's not a closed circle, we don't want to include the 3, but all the values that are less than 3. Okay, so far so good, I hope. -1, -2, -3, -4, -5. We're looking for all of the values of x that are greater than or equal to -5. It's pointing up in the positive direction, so the numbers are getting larger. So we're looking for values of x that are greater than or equal to, because it's a closed circle, -5. Now we got to do a little bit of work. Not too bad though, right? We're going to add 5 to both sides, and I get 3x is less than or equal to 6. Okay, we ask ourselves, what's being done here? This is 3 times x. So to undo that multiplication, I'm going to divide both sides by 3, and I get x is less than or equal to 2. So if we wanted to graph that, we're going to go 1, 2, 3, close circle on 2. We're looking for values of x that are less than or equal to. And if we were putting it in interval notation, we're going from -infinity up to 2, including number 2. All right, again, we're going to solve the inequality. This time there are variables on both sides, so I'm just going to try to get my variables together. Minus 2x from both sides. 2x take away 2x is nothing. 3x take away 2x leaves me with an x. So I'm going to get this 7 over here with the 4. So take away 7 from both sides. 7 take away 7 is nothing. -7, -4 take away 7 is -11. So again, if I wanted to graph it, -12, -11, -10, closed circle, pointing to the left. All the values of x that are less than or equal to -11. Okay, this is the ones that typically give people some fits. Okay, this whole thing is being divided by 4. So we've got to look at that first. This whole problem up here on the top is being divided by 4. So we've got to undo that division first by multiplying both sides by 4. 4 over 4, right? This is being multiplied by 4, so it ends up with a 4 on top and a 4 in the denominator. That's just 1. 1 times 6x minus 12 is just 6x minus 12. 3 times 4 is 12. Okay, so we're going to add 12 to both sides. So I have 6x is greater than or equal to 24. Divide both sides by 6, and x is greater than or equal to 4. So we're going to go up here to 4, put a closed circle. We want to look at the x values that are greater than 4. Okay, now it says write this inequality in words. So we need to know, what is this saying? This is saying 2 times some number x, 2 times some number x minus 5, or take away 5, however you, or decreased by 5, is greater than 7. And I should probably write out the words 5 and 7, but for the sake of time, I'm not going to. Okay, so this one says to write the solution in interval notation. So we could go ahead and distribute first, or we can divide first. Either way you go, you're going to get the same answer. And I think it'd be easier just to divide both sides by 4, so that cancels out. 8 divided by 4 is 2. So I end up with x minus 7 is less than 2. Again, all I did was divide both sides of the inequality by 4. Now I'm going to add 7 to both sides, and x is less than 2 plus 7, which is 9. It says to write it in interval notation. Now, I like to look at the graph when I go to write it in interval notation, just because I guess maybe I'm a visual person. But we're looking at the values of x that are less than 9. So it's pointing way down here. We read the graph from left to right. So I'm starting at, it's pointing down here at negative infinity, and it comes up to 9, and we don't include 9. So it's written, this is my answer, written in interval notation. All right, let's try this next one. Again, I would go ahead and just, that's the same problem, isn't it? I think it is. Yes, I made a mistake. Sorry about that, guys. So we can skip that one. Going down to the next one. Solve the compound inequality and write the solution set in set builder notation. Okay, so we're going to put it in set builder. We've got f minus 6 is less than, I made all kinds of mistakes on this. F minus 6 is less than 2, and f minus 4 is greater than or equal to 2. So we're going to solve this compound inequality. We're going to begin by adding 6 to both sides. So we get f is less than 8. Then we're going to add 4 here. And f is greater than or equal to 6. So let's think about this. We're looking for values of f that are less than 8. And at the same time, they are greater than or equal to 6. So what numbers meet that criteria? Everything right here in this overlap, right? Starting at 6 and going up 2, but not including 8. So our solution set would be f, such that f is sandwiched in between 6 and 8, and it could be equal to 6, but not equal to 8. So I just put my answer in set builder notation. That's this right here. So we solved it first and then put it in set builder notation. Okay, so this one says solve the compound inequality, and it's written as one big old problem. So the first thing I like to do is kind of divide it up. I look at this one first, and then I look at this one. So I'm going to say, okay, I've got 3b plus 2 is less than 5b minus 6. Let's solve this one. Subtract the 5b, I get negative 2b. Subtract 2, I get, what would that be? Negative 8. Divide both sides by negative 2. Remember the golden rule. If I divide by an inequality, I've got to flip that symbol. So b is greater than 4. Okay, now we're going to do the other side. 5b minus 6 is less than 2b plus 9. Subtract 2b from both sides, I get 3b. Add 6 to both sides. 9 plus 6 is 15. Divide both sides by 3, and b is less than 5. Okay, so thinking about this, we're looking for values of b that are greater than 4 and less than 5 at the same time. So I've just put it in set builder notation. If you want to look at the graph, we're looking at values that are greater than 4 and less than 5. So it's all of these numbers in between 4 and 5. Okay, let's solve this next compound inequality. We're going to subtract 14 from both sides. So t is greater than or equal to 15. Take away 14 is 1. I'm going to add 9 to both sides. T is less than negative 10 plus 9, which is negative 1. So we've got t is less than negative 1, or values of t, we're looking for values of t that are greater than or equal to a positive 1. So here is our solution. We need to put that word or in there. We can have these solutions down here or these solutions down here. If we put that in interval notation, we're going to say we're looking for values from negative infinity up to negative 1, not including either one, union with values from 1, including 1, up to positive infinity. If we want to put it in set builder, we're going to say t such that t is greater than or equal to 1, or t is less than -1. Okay, solve this compound inequality. I'm going to give you a second to try it. I'm going to pause the video. You try it. I'm going to work it out and then unpause. Okay, I hope that you worked this out. This one's a little bit different, right? We end up with n is less than -3. If you remembered the golden rule of inequalities, when you divide it here, you end up with n is less than or equal to -3. So these look very, very similar. When you graph them, one's an open circle, but then you put that closed circle over top of it. So if it could be this one or this one, why not just say it's this one? Because this is included in this. So my solution would just be n's less than or equal to -3. Because again, this solution set includes this one inside of it. So there's no point in writing them both. Okay, so this says write a compound inequality to represent, that's what that says. You can't see it, but it's there. To represent the graph below. Must have been in a hurry on this. -1, -2, -3, -4, -5, and 1, 2, 3. So we're looking for values of x that are sandwiched in between -5 and 3. They are less than 3 and they're greater than -5, not inclusive. So there is my compound inequality that shows this. If you wanted to get really fancy, you could come up with a problem, but this is good enough. Like, I don't need anything else. It says write a compound inequality to represent this graph below. So here we're looking for, this is -1, -2, values of x that are less than or equal to -2, or we're looking for values of x that are greater than a +1. So there is the compound inequality that represents this graph. All right, so now into the fun problems, the absolute value inequalities. These are my favorite. Remember, the first step is always to isolate the absolute value, to get it all by itself. And here this absolute value is all by itself on this side of the inequality. So that part's done. The second part is to decide if it's an and or an or. And we're looking at this. This is less than, so it's an and problem. So I've got x plus 8 is less than 16, and x plus 8 greater than -16. We changed it from a positive to a negative because this is absolute value, so we have to have our two cases, and I flipped the sign. So if I subtract 8 from both sides, we're looking for x's that are less than 8 units, and we are looking here at values of x that are greater than -24 units. So let's think about this. Okay, we're down here at -24. We're up here to +8, right? Subtract 8. So we want all of the x's that are greater than -24 and all the x's that are less than 8. So my solution is all of these numbers here in between -24 and 8. What that really means is all of these numbers in between here are fewer than 16 units away from -8 on the number line. If you think about where -8 is here, there would be 16 units between -24 and -8, and then there would be 16 units between -8 and +8. All right, let's try this one. Again, I'm going to pause the video. I hope that you pause it and that you take a second to work it out, but rather than you see me write it all, I'm going to pause it and do it, and I hope that you pause it and work this out as well.